the next lesson that we're doing, and the final one in this series, is looking at working with natural logarithms. So we've already seen exponential functions which have this form, and we know that logarithms are the inverses of exponential functions. So we've got the graph here in the red of y equals e to the x, and this one here is log r to the base e of x, the inverse. And we know from our work on functions that the inverse of a function, the graphs are related because they're reflections in the line y equals x. Now, why have I written ln x? Well, that's a shorthand notation for natural logarithm rather than writing log to the base e. And there's a useful relationship there, and that's just using the power rule there, thinking about functions and their inverses. So what we're going to do is we're going to look at solving some equations where we're going to use log to the base e or natural logarithm to solve these equations. So just like last time, we're going to take the log of both sides, and I'm just going to write it as log to the base e first of all, and that can be written as natural log of e to the x equals natural log of 5, which is a quicker way to write it. Then we're going to use the power rule here, so we're going to rewrite that as x natural log of e equals natural log of 5, and this is saying here, let's just write this in a different colour, this bit here is saying log to the base e of e equals what? Well, what power do I have to raise e to give e? Then the answer is 1. So this is simplified to 1. So actually our final answer, let's write that in a different colour again, is x equals natural log of 5. And when it says give it in exact form, we don't work it out, we leave the answer like that. Let's look at a second example. Again, slightly more complicated again, but we're going to take the natural log of both sides, and we're just going to write it as natural log first of all. Then we're going to use our power rule to rewrite this side. I'm going to use brackets. 2x plus 3 is natural log of e is natural log of 7. And what we remember, what power do I need to raise e to give e? This is just equal to 1. So that simplifies things. You can always check that on your calculator. So we get 2x plus 3 is natural log of 7. So we can rearrange that to give x is natural log of 7. Let's put brackets around. Take 3 divided by 2. So then I don't confuse putting the 3 in there. And obviously I could work out an exact value for that. Let's look at one final example, which is this one, which you might be thinking, I've seen this before, it might look a little bit like a quadratic. So let's use a substitution first of all. Let's call y is equal to e to the x. So I can rewrite this as y squared plus 5y equals 14. And what we'd normally do is make one side equal to 0, like so, and then factorize. So we've got y plus 7 and y take 2. So we get y equals negative 7 or y equals positive 2. If we substitute back, e to the x is negative 7 and e to the x equals 2. We should already spot that this one, we can't have that. If we think about the graph of the exponential function goes like that, it doesn't venture below the x-axis, so we can discard that particular solution. So if we go on to this part here, we're going to take the natural log of both sides, as we did previously, use the power rule to rearrange that. We know that what power do I need to raise e to give e? That's equal to 1. So x is natural log 2 is the only answer. So that now brings us to exercise 14G on page 327.